All right, this should be the correct window, I guess.
Yeah, it's loading.
All right, that looks good to me. Cool. So welcome everybody. This is the first time actually I have this talk. So either it will go complete bullshit or it's going to be fine. Let's figure out at the end. As already said, thanks for the nice introduction. I'm Manuel. I'm working as the head of product open source at TrafficSplits. I am now a Traefik maintainer on my own for, I guess, 4 years or even a bit more by now. I really started joining the product early as just a voluntary freelancer. And then I finally joined up with TrafficSplits in June 2019. As a bit of a weirdo, I started at the sales side of things. So I started as a solution architect. But after roughly half a year, so at the beginning of 2020, I switched over into my current position because, yeah, it's just the better fit. So I'm, as the name suggests, my full heart and soul is into open source, so I'm advocating around it a lot. I used to be a software engineer before, so I do Go mainly, sometimes also Node, Python, and like very, very back in the days, I also did some PHP, but I really try to forget these crazy times, but it didn't work out yet. I'm focusing on all the container things that are available, and I try to keep put there. As already said, I try to speak and share knowledge and all of that around various occasions. So this is one of it. For the sake of the talk, we want to look at Ingress management and how things are, or how things used to are, let's say. So at the first, let's look at the past. Let's open up the history books and see what's up. So this is a pretty typical Ingress example. You probably all know from your from your daily work, from when you run Q.
Sorry, Manuel, I don't know if you have changed the slides, but I cannot see a new slide. I don't know, perhaps the others can.
No, it's stuck for me as well, yeah.
It's stuck? All right, then let me see, wait.
It's stuck.
Is it better now?
It's stuck on the, who am I? No.
We are still on the first slide, I think.
Yeah.
This is weird. All right, let's try this again. And now?
Yeah, just a minute. It's loading. Can't see it yet. It's a black screen for now.
A black screen? Well, that's something new.
On my computer, at least, yeah.
Yeah, on mine too.
Yeah.
Maybe stop and start it again.
Yeah, I already did so, but of course,
yeah, I know.
I'm happy to do it again. Here we go, share it again.
Yeah, we see that you're sharing something, but it just says that the sharing started, but with a black screen. So yeah, maybe try not to go full screen. That's some suggestion we have in the chat.
Yeah, I'm already trying, but let me try like another window. Maybe that works.
Yeah.
Who knows? All right, and back to Zoom it is. Still black or better?
Yeah, no luck. It's not displaying. Yeah, finally, now it's fine.
Yeah.
It's there? All right. Then I try to zoom in. Oh, that's not really working fairly well.
Maybe try to go in full screen mode now that we see your screen. Maybe it should. Yeah.
Yeah, now
that's good.
Try to change.
You still see something?
Yeah, we see.
We still see, but can you change the slides? That's the part that wasn't working.
I changed.
Now it's nice. Yeah.
It's good.
Oh, okay. I did exactly the same thing again, but whatever. Sometimes it's Zoom.
Sorry, Manuel. Sorry.
No problem. So yeah, this is the regular Ingress. You all probably know. It's a resource It's a resource in Kubernetes that is integrated for a long time, which you can see we by now have 3 different API versions for that beast, depending on which Kubernetes version on itself you're running. The use case for the Ingress API, you all know, is simple to use for basic Ingress traffic, right? I mean, you have a host, you give it maybe a path, you tell it which service to run for. But I mean, yeah, that's all pretty simple, right? What it recently received some updates, some more love in introducing a new resource called Ingress class, which is used to instruct the Ingress controller to go for which ingresses he should be carrying on, which he should be working on. So it is getting some updates, but it's still, let's say, not very optimal. Because if we look back at the Ingress resource, you will know, and you all know this, when you want to customize behavior of that resource, what you usually do is doing annotations. Like you put some weird basically key value strings on top of the resource, and then you can instruct the Ingress controller to handle things a bit differently here. The problem with that approach is pretty obvious though. You have a total vendor lock-in, because if you can see, the annotations, they differ between the different Ingress controllers that are available on the market. So having functionality in one Ingress controller doesn't necessarily guarantee you that this exact functionality is available in the other Ingress controller and is also exactly configured the same. Therefore, it's super hard to compare configurations because they just differ a lot. So there's not like an easy approach. As I already said, the features provided by the Ingress controllers, the scope of the features provided differ sometimes a lot. So you can't even easily exchange your Ingress controller because it's just a different beast. So there's really some work involved if you wanna hop on that train. Last but not least, annotations are really hard to maintain, as you probably all already saw and felt in your daily work, because as I said, it's just key value pairs, right? So you can literally write in whatever the heck you want to have written in there, and there's no checks or nothing. So you just put it in there and you hope that it works. So that's a bit unfortunate. However, we have somehow learned to live in that scenario, right? I mean, we are kind of used to that dumpster fire around us by now, but there's some evolution, because what then has been done, for example, by Traefik or also by the Contour guys, is we have introduced custom resources to overcome the challenges. Like the idea of CRDs in Kubernetes, and you probably all know it, is to put in custom resources that are tailored to your actual needs. And therefore, the resources in itself are way more declarative and fitting the actual use case, because you get a way of having to maintain all this key value mess, aka annotations. But the solution itself takes a fair amount of maintenance, because you have to maintain your CRDs, you have to upgrade the definitions, you have to make sure that these definitions work on different versions on Kubernetes and all that dumpster fire that is around this. So this is still really some work involved. Last but not least, it doesn't really tackle the other issue that the feature set differs between different solutions. And not just that, I mean, those custom resources are not interruptible. So you will have to rework basically everything if you change the controller. So that's probably not really optimal again. So we have the past with the Ingress. We try to overcome the solution with the Ingress with CRDs, but that's not really working as well. So let's take a look at what could work, because it's not proven yet, but it could work. And this is Google doing Google things, basically. But this time, maybe it will really help us in solving everyday's problem. What they started and what is and what has been worked for more than a year by now is something that is called Service API. Service API is basically a subset of custom resource definitions that will be needed to be installed in your cluster. And one of this subsets, let's say, is called Gateway API. And at this, we will take a look today. The whole movement around the Service API, or specifically around Gateway API, has been announced at KubeCon US 2019. So that's when the work has been started on that. The Service API in itself provides a clean separation and role-based control across its model, and we will see that in just a bit. It's meant to up-level the Ingress specification in a whole, so it specifies standard methods of extending the Ingress and on how to better customize the actual behavior. However, it is meant to be used in complex cases. Like, Ingress still has its beauty, right? If you have like 3 services, you want to have a simple way of exposing to the internet, you would probably not need Service API. But if you're running a bit of a larger cluster, you might have separation between people like deploying apps to your cluster and running your cluster and things like that. This is the case where this new API could come in handy, let's say. So at first, the API currently is in a super early stage. The V1 Alpha 1, oh, there's actually a typo because it's V1 and V2, not V10, but whatever. It's available as of January this year, so it's still quite fresh. It's not yet bundled with Cube, so if you want to test it out, you will have to manually install the CRDs to your cluster, but that's like easy. And a couple of vendors have announced and already integrated experimental support, and we are part of this movement as well, because we are contributing and actively discussing this the specification with the whole network special interest group on Cube since it all started. So it was a no-brainer to also include support. What does the API actually provide? Well, the API provides, oh, and there's another typo, I'm so sorry, it's 3 and not 4. 3 new CRDs by now, which is the gateway class, the gateway, and a route. And the chain of flow is like, there is a gateway class, and we will see on the next slide what it is, which is linked to gateways, and gateways are better routes are linked to a gateway, and the route is what could be best compared with the current Ingress, and from an Ingress it goes to a service. So for the gateway class in itself is meant to be a cluster scoped resource. It could be best compared to just a category because it represents a category of Ingress controllers, basically. It's very similar to the former well-known Ingress class annotation or the now introduced Ingress class resource, because it's from the ground up, it's the same. It is expected to have 1 or more classes inside your cluster. So it could be a class per vendor, for example, Traefik, or it could be a class that manages internet access to your resources, or a class that handles private access from within your cluster. So there are literally no borders. You can, as you just see it as a category, it can be whatever you want. The cool part about a gateway class is it can have default settings for different things, like for default routes or the default ports to listen on, and for default configuration in general, let's say. It can, however, pass further configuration to actual created gateways. So if there is a default configuration to be made on every gateway from that class, that would be the case. Usually, as I talked about role separation, this resource can be managed by either the infrastructure provider. So for example, Google Cloud could have predefined gateway classes for specific gateways, or by the highest cluster operator in your company, let's say. The resource right below is an actual gateway. So a gateway could be seen as a one-to-one life cycle integration with actual infrastructure. So one resource, one gateway resource corresponds with one either physical or software existing load balancer, which could be, for example, an elastic load balancer on Amazon or an instance of Traefik, because that's the one-to-one linkage. A gateway is linked to a class for configuration. So if there is default configuration made on the gateway class, it will be passed to the gateway, and so you can go with that. On an actual gateway, and we will see that in the examples, you will set your listeners and on which routes to run. So you have the set of what will be done on this resource. The gateway in itself has a lot of possible protocols, like for sure HTTP, HTTPS, HTTP2, TLS, TCP. So it's a full-fledged spec. However, everything that is not HTTP or TCP is a little more in work these days. And this resource is expected to be managed by a cluster operator. If we look at the two things in action, you have a gateway class on the left, which is like with a specific controller, so the controller can see that it's like this class really, and then you can pass some basic configuration, for example. And on a gateway, you link it to a class. So it could infer default configuration, and then you put in you define your listeners, like if it's on specific IPs, for example, or just on protocols. There is some application, for example, HTTP implies port 80, HTTPS implies port 443. So there's some further magic. And in case of HTTP or TLS, you can start putting certificates there right away containing your TLS certs, basically. And then in the routes part, you link it like where to go, but we will see that in action in the live demo. For the routes linked, what is a route? As I already said, a route is basically best compared to the old Ingress. It describes a way how to handle traffic given protocol level descriptions, such as host, headers, paths, things like that. There will be different, or there are different route resources for each protocol. So there's an HTTP route, there will be a TCP route, and all those things. It can delegate to other resources. So let's say you have a route for a service, but this service is managed by another team in your company. You can delegate even to things outside of your namespace, for example, and just pass it to the other resource, for example. And this route is typically managed to be by actual app developers. So app developers that wanna make their app accessible from the internet, they would use this. If we look at the actual route, we see this is not looking that different, right? You have a couple of rules which need to match, for example, and a host and a path prefix. And then you could tell it, for example, to delegate to the other, to a namespace of another team, which has also an HTTP route there. So you can chain your things in case you need, or you could also just, and that's what we will see in the demo, just target a service directly, for example. So whatever floats your boat or whatever you need. What this specification also does is it offers the possibility to do Canary releases. So you still have your HTTP route, there is no change, but there is an option in the forward to path where you could place different service names with a weight, and then it would go from there. What we see at this, and what is the huge benefit, for example, Canary releases these days in the typical Ingress controllers, they all require a different configuration, right? You either have to put in crazy annotations or install some CRDs or whatever, but with that specification, it will be the same. Like whatever vendor you're going to use, if he supports this specification, everyone will support Canary releases the same way without having any issues at all. So that's pretty cool. For that part, I've finished the theoretical part. So if you have questions until here, feel free to shoot. Otherwise, let's see that thing in action. So that doesn't sound like questions. So I'm gonna have a sip of water. All right, and then we go. So I have to change my screen share now. Pray to whoever you want to pray to that this still works. Let's stop and let's share. I want to have this and this. You should see two things. Is this right? Do you see two things?
Yep.
Awesome. So this works, at least for now. Let's hope it works long enough. So on the right, I have a terminal. I increased the font size. If you can't see things, just tell me. This is a fresh cluster created locally with K3D, so nothing special. It's just a simple cluster. If you look here, there's not a lot to see. It's just a couple of things, so that's all right. As I already said, the first thing we need to do is install the subset of CRDs because they are currently not bundled with Cube. So we quickly apply the subset of CRDs, and there we go. From here, let's quickly install Traefik because it's one of the Ingress controllers that's supported, and so why not use it? I have already added a Helm repo to our Helm chart. If not, you would need to do it before. And from here, the only thing you need to do is actually call in Helm install. And what we have done to make access to this specification a bit easier, because we want, like I said, we personally believe in this, and therefore we want to make access to this as easy as possible. So in case you want to install Traefik and run this, there is an experimental flag to be passed to Traefik, and this will start the whole thing. So I just fire it up. What it will now do is it will, of course, make the deployment of Traefik, pass the parameters that we need to Traefik in order to tell it, hey, please run this provider. But also it creates the gateway class I already mentioned that needs to be created. And it also, oopsie, there's a typo, I'm sorry. And it also creates the gateway. So that's cool. We can see that Traefik is hopefully up and running already. Yep, it is. So what we can quickly do is start a port forward, so we can quickly look at the Traefik dashboard. And what we see here is, if we go to the actual dashboard, that all three Kubernetes providers, like the typical Kubernetes Ingress, the typical Kubernetes CRD, and also the Kubernetes Gateway are running. So that installation worked. So far, so good. Let's quickly open another. Oh, that was too large. Another tab on my shell. There we go. So connect to the cluster, kubeconfig pods, kubectl, get pods. There we go. Okay, cool. So what we're now going to do is spawn up some services. The first thing we need to do, because otherwise, like we need something to go for, right? So we need a dummy service which we can target. And what we're going to target here is the famous Traefik UMI service. So it's just a simple deployment with an example app and just a service. So nothing too crazy here. I really can't type today. That's crazy. So deployment is there, services there, everything's simple. To make access to this, we need the actual HTTP route, as you probably have guessed. So it's a simple HTTP route. It has just a name, a namespace, all good. What it needs is something to match. And if we look at the gateway, we will see that kubectl describe gateway traffic. We can see that this gateway has a selector with match labels, and this label matches on, or it will match on labels app double-point traffic. So therefore, we need our HTTP route to have a label of app traffic. So that's pretty obvious. So when we deploy this, we see that this got created, and refresh here, we will have, hopefully, hello, what's up? That is unexpected. kubectl logs. Because the UMI service is not there yet. That is the problem. Why is that? Oh, because my local cluster has this pressure. Why is that? That's unfortunate. Maybe I can put it down to one replica. Maybe that will be enough. I don't know. Let's see. See. So maybe that helps. Well, at least it's pending. So maybe. Nope. All right, let's quickly just get rid of that whole cluster because that's what we can do. Go into my Docker settings. Give it some more disk space because why not? Are there questions in the meantime? Nope. Okay.
So the SSL offloading happens on gateway on the routes.
Sorry, I didn't understand properly.
Hi. The SSL offloading happens on the gateway or on the routes?
On the gateway. On the gateway,
Right.
and we will see this if the cluster is working in a minute.
All right.
There you can define whether it's an HTTPS or a TLS listener, you can give it a certificate, and then it does the SSL offloading there.
All right. Okay. Thanks.
I'm just waiting for my Docker daemon. Like it will probably take 1 minute or so, and then let's try that again. It's already starting up, so. Come on, Docker, don't be that slow. There we go. So Docker started up. So place really, let's create that shit again. Dum, 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 dum. Apply the CRDs again. There we go. So let's quickly install Traefik again. And then you see go to UMI HTTP route. So we can do the port forwarding here again. Still not there yet. It's running. So. That doesn't seem to be my day so far. Ah, no, I know where this is. There we go. So this was having, and there we see it. There we can finally see that there's the new HTTP route, which got detected. We have OMI, no path, and to the actual router. So that's cool. So if we do a quick call request to this, like just to my local host where my cluster is running, and we set the host to who am I, we can see the response. So finally, that is working. The next step, or the next I want to show you, is how this works with paths. So we had another HTTP route which goes to the same service, of course, but which matches also the path of foo. So if we apply this, and we now do the curl from previously with /foo, we also get the response. Woohoo! So that's cool. But that was so far pretty simple, right? Now to the example or to the question for where TLS termination is made. if we look again at kubectl get gateway and then gateways, and writing properly will probably be good. kubectl describe gateway traffic gateway. Same typo. We see that that currently we have one listener which is running on the Traefik port and which has the protocol HTTP. So that is so far okay. But what we want to do now is we will do a Helm upgrade with this value file. And what we can see is that we will pass the certificate. To it. So what we need to do first is actually apply the dummy certificate, which is in place, and then run a Helm upgrade command with the value file I just showed you. So there we go. With that in place, we just describe the gateway again. And what we can see in here, that it now also provides a second listener on port HTTPS, which has the TLS certificate attached. So now, if we do the curl from previously, but without changing anything on the configuration, but just put in HTTPS and say insecure because it's a self-signed certificate, we get passed through with the same answer, and that's it. We just have TLS termination without changing anything of the actual routes. So the last thing I want to change to show you, because I briefly touched it, is Canary releases. For that first, we need another service to run as well. So let's quickly just deploy a simple Nginx because it shows something. And then we look at the HTTP route configuration. And there we can see that we now have, as in the example, 2 forward to targets, but with wait options. So kubectl apply. And the who am I? This is configured. So far, so good. So, and as we have in here, it's only matching on the host who am I, right? So if we do curl to who am I, we have the first, the second, and there we go. There is the Nginx. So that's pretty sweet. And that's for the demo part, that's all. So going back to the slides, that everything I had to show you. There are, of course, currently a couple of known limitations, such as we are currently only handling HTTP and HTTPS, and we will add support for TCP and potentially also UDP in the future and things like that. But this will all evolve with the specification, and while evolving the specification, we will, of course, add this as well. So if you have questions, shoot.
Manuel, I think you briefly mentioned it in the beginning. What are the main reasons that someone would prefer to go towards this method rather than the old, let's say, Ingress method?
As I quickly touched it, and I can go to this. This whole specification, like I said, is probably not meant to replace Ingress entirely, because, as I said, especially in small deployments with not too many hosts and stuff, where there in itself is not much separation between people like running the cluster and only using it to deploying apps and stuff. There's probably not many movement to go to this. But where this can help is as it provides separation on different resources and things like that. when you're actively working in huge corporations or bigger companies, let's say, where there is separation between people running the cluster, people deploying apps to it. Because, for example, with the embedded role-based access control, you can deny actions on certain of the items, right? So you can, for example, split the TLS offload handling assets on the gateway from people that only care about deploying applications because they only need your route object, right? So as soon as like the amount of people that want to use your cluster, and maybe where most of the people are regular developers that only care about pushing their things into production, which is a good thing, then this can become helpful because you separate the roles from different people with different jobs, let's say. Plus, it will help you in being interoperable with with other people, because if you've, I think Contour will add the same support as we do, and you could theoretically just like remove Traefik and place Contour, and everything will work the same because it's all in the specification. So yeah.
Hi, I have another question, please.
Yeah,
so
sure.
You also talked about like the difficulties and of annotations. Are you actively trying to consolidate annotations across like Ingress controller vendors to be the same, or like have it in CRDs more type safely, let's say, in a more type safe manner rather than have it on annotations? And
No, go ahead.
No, and the annotations would be like a concern of the gateway, right? On the HTTP routes would only handle the things like rewriting or like directing traffic to specific services, right? So you are separating nicely the concerns of infrastructure and application.
What on this, what all vendors, at least I talked to, agreed on is that once this service API thing has reached a given state that we don't need our CODs anymore, we will probably consolidate in at least moving the CODs to the service API CODs, let's say, because then there is no more sense in having them. For example, for rewriting and stuff, what the service API offers, but which would like make this talk even longer, is the concept of filters. For example, you can define filters, place them on your HTTP route, and then you could handle things like redirection. So in a standardized manner across all vendors. There is currently, at least not that I'm aware of, a movement to make standard annotations. I think because of plain complexity, like making all those things backward compatible, every vendor with a specific subset of CRDs we would all agree on and stuff, that's pretty complex to achieve. So but I might be wrong, but I don't think that this is currently planned for anybody. I rather think that we will all work towards having something like Gateway API stepping in and making us interoperable. Because if you look, for example, I mean, it's not just vendors, also big players like Amazon, for example, would need to chip into the Ingress part because their ELB handles things differently than, for example, Traefik or Nginx does. So coming to something which is shared across everything on an annotation level, I think that's going to be complex.
Yeah, probably. Thanks.
No problem. Next question, if there is one. Doesn't sound like that. That's good. If you have feedback afterwards, feel free to reach out. Best case for me is pinging me on Twitter because that's what I see regularly. And yeah, other than that, thanks for listening. I hope the broken cluster was not too much of an issue for you.
Thank you, Manuel. Very nice presentation. And you did well with live debugging, so congratulations. It's never easy, even if you pray the demo gods, we all know that. Huh? So if we don't have any more questions, I think we can close this session. Maybe 10 more seconds for questions for Manuel, if you have some.
I can maybe like one thing to leave. If you want to play out with this, and I will post it to the chat. We recently pushed a blog post for this. So there's also all the examples linked from that I just run. So if you want to play it on your own and try it, just go for the blog post. There's everything explained with configuration files and stuff. So you can give it a go on yourself.
That's great. So we'll link this post along with the recording of this session so that if anybody misses it, we'll share it on our social media so you can get access to it. We'll also link the recording of your presentation, Manuel.
Thanks.
Thank you. Thank you for this great presentation and great demo skills.
Thank you. It was fun having you. Thanks for having me.
Thank you.
It's a pleasure.
All right.
Thanks.
Enjoy your evening,
Manuel.
folks.
Yeah. Thanks, everybody, for
Bye-bye.
joining, and see you at the next Cube meetup. Thank you.
Bye-bye.
Bye-bye.
Bye.